related to EU-funded initiatives, projects that are related to XR community and boosting better in the education with XR technologies. So now I will give the floor to Massimo from Sapienza University. Massimo, do you want to introduce yourself?
Good morning to everyone, and thanks for coming here in Rome. And I will give now a brief welcome from the Sapienza, that is the hosting institution today to this event. Unfortunately, the opening should have been done by the director of our department, Tiziana Catarci, that has a sudden institutional, and so he sent me on her behalf. On one side, this is bad because as Ioannis knows, Tiziana is a female professor, and in this world of STEM, you surely prefer to have a female director, and you have me that I'm surely less attractive, but in the meanwhile, I am the director of the degrees here in Sapienza in engineering, computer science, artificial intelligence and robotics, and a new joint EU master on artificial intelligence financed by the EU Commission. And we are very proud to host this event today and all the kickoff meeting of the project, because we believe to have we are somehow the maker of the movement of the trends that the project is about. We worked in particular in Sapienza, is one of the largest universities in Rome in terms of registered students, and we are the top ranked in Italy, in particular on the topics of computer science and engineering, that are the disciplines that are behind, one of the disciplines that are behind extended reality and technology enhanced learning in general, that are the topics you are interested in. Our department is one of the top ranked departments in Italy. In particular, 5 years ago, we were awarded as Department of Excellence. That is a special prize that the Ministry of Research gives to about 100 departments all over Italy in all disciplines, and we were awarded in order to have improving the teaching structures, the research staff, and the personnel. We have, let's say, a good reputation. We have 2 ACM fellows, 2 RC advanced grant, 4 AI fellows, and so on. We believe too that we are the right institution to host events like this one, and this is why I will welcome you, because we work very often with AI, and we believe that AI and extended reality are 2 phases of the same gold, basically, of the same medal, because in the world in which we will have more and more extended interaction, surely the components of intelligence that you will have in the extended reality will play a relevant role. On these topics, we also started very recently a new degree on artificial intelligence and ethics. And I mentioned this because I believe that also in extended reality topics, you are investigating, for example, the issue of learning, there will be a lot of ethical, let me call technology-driven ethical concern. I'll just make an example, which is the value of a test done on extended reality settings instead of having on the physical world. In many settings today, if you have a real test bed, you can say from the law, for example, that this is valid and the product can go on the market. What happens if we do this on an extended reality framework? The ethical implication, the social and legal implications are new. And so we believe that these types of problems are those ones that should be investigated as well in the future, in context of large projects are the one that we'll witness today. I think that, so I repeat, we are very welcome to host you. We hope that this will be the first one of a series of events that probably will be organized in the context of this initiative of the EU Commission. We are very proud again to host you, and thanks you for those that are in Rome. There are a few persons here in the room, but especially also to those ones that are connected remotely. Thanks.
Thank you, Massimo. And now we will give the floor to Luis Eduardo Martinez and Rositsa Georgieva that will speak on behalf of Health and Executive, European Health and Digital Executive Agency.
Hello, can you hear me?
Yes, we can.
Okay. Hi, I'm Luis Martinez. I'm the project officer of one of the projects from today. My background is in startups and economics. And well, these projects are part of the new framework program Horizon Europe. I'm part of the topic 119, Extended Reality Learning, Engage and Interact. And the main objective of this topic is to develop innovative extended reality applications for learning, training, and education, as well as to test and support take-up of proven and successful extended reality tools, with the overall objective of making Europe a leader in cutting-edge technologies for education. Due to its low presence in the consumer electronics industry, Europe is increasingly dependent on external providers in the area of extended reality, raising concerns about its digital sovereignty. And with the COVID-19 crisis, we have seen how important distance and innovative learning are for our society, for our children, the parents, and the teachers, and maintaining social and educational links under challenging circumstances is critical. Emerging technologies such as virtual reality, extended reality, or immersive environments provide numerous opportunities for personalized, innovative, efficient, and inclusive learning for learners of all ages, gender, and condition. And we want to gain industrial leadership in extended reality technologies and immersive environments, while also ensuring that European values of privacy, ethics, and inclusiveness are maintained and respected. Going back to the projects, I'm eager to hear more about them, and hopefully we can have some collaboration opportunities, maybe a final joint event from other projects in Brussels or something similar. That's it from my side. Thank you for the time.
And thank you so much for these opening remarks. We will start our talks about projects that are funded under extended reality. Okay, then we will give floor to her.
Dr. Georgieva, do you want to also address the audience?
Hello. No, I wanted to say thank you for the invitation. I'm the project officer together with Luis Martinez for another of the project, and our colleague Diana Miashkova. She's the project officer for the third funded project under the same co. We'll work together, and maybe Luis very well emphasized the importance of the co and the results of the projects. Maybe on my side, I want to also link it to the policy work because, you know, being such an important topic, we also work very closely with the policy officers in the European Commission, and often we'll come back to you and to your stakeholders for more feedback to policy, as we call it, of what it's the necessary next steps and how we can cooperate in order to improve the situation and improve the skills and the use of the extended reality for the training and education. Thank you so much.
Thank you so much, Dr. Georgieva. Now we will start the part of the session, which is dedicated to introducing you to the projects that were funded under Extended Reality Learning, Engage and Interact Horizon Europe call. The first one to introduce itself is the project Master, which is about mixed reality ecosystem for teaching robotics in manufacturing. We are now kind of asking Panagiotis KARAGIANNIS from University of Patras to take the floor.
Okay, thank you very much. I hope that you can hear me well, and you can see also my screen. First of all, before I begin, just let me apologize. I'm now in between some travels, and I'm at the Vienna airport, so hopefully the connection will not betray me, and you can hear me well. So starting, I would like to thank Ioannis and his team for this very nice initiative and for this opportunity to meet with all the sister projects and know a bit of each other, and also to give me the opportunity to speak about our project for the first time, let's say, in public. We have our kickoff meeting next week. And my name is Panagiotis KARAGIANNIS. I am a project manager in Laboratory for Manufacturing Systems and Automation, or LMS for short, from the University of Patras. And I'm also here with my colleague, Katerina Pakopoulou, who is also a research engineer in LMS. So a short introduction about the call expectations, let's say, has been already done by the project officers. So I will try to dive in directly, let's say, to the master project. Master stands for Mixed Reality Ecosystem for teaching robotics in manufacturing. So practically, in a nutshell, the objective of master project is to boost the ecosystem of the extended reality. We will be based on an open XR platform already developed by one of our partners, enhance this platform with several key functionalities from technical partners within the consortium, which functionalities will focus on the creation of safe robotic environments, on the provision of flexible programming applications, and on providing advanced interaction mechanism between the human and the extended reality platform. And on the other side, another goal is to create training material inside this platform in order to help people to use the extended reality technologies on robotics applications in manufacturing. In parallel, we have another, let's say, dimension to consider, and that is of the contribution from third parties through two open calls. The first will be focused on technical aspects. So the first open call will be focused in the technologies that will be also developed by the consortium, as described in the first bullet. And the second open call will be focused on the creation of education material and the validation of this extended reality platform developed by Master. So moving on, we have certain technical objectives that are related also to the developments that I mentioned before. The first one is to enhance and provide an open platform through which people will be able to be trained on robotics applications using extended reality application. The other one is to have a virtual environment in order to program and interact with the robots inside a safety and safe environment. The third one is that we aim to close the gap that exists right now between the virtual and real resources, helping the training and helping the training activities of the operators when using the real robot resources. And the last one is to help them using this virtual environment in an immersive way by providing different modalities for interaction. As I said before, one of the aims is to close the gap between the real technologies, the real resources, and the virtual resources. And for this reason, we have an industrial objective to help the companies, and especially the SMEs, of course, which is the typical suspect, let's say, that we are targeting in the research projects, in order to help them be familiarized with the new XR technologies and help them create new tools in an existing platform, integrate those tools, and help them spread those tools to different stakeholders in order to be used. And another objective, also related to our activities, is the educational objective of creating new material, both, as I said before, from within the consortium and outside the consortium through the open call using new extended reality technologies. Here in this schematic, you can see our approach, let's say, in the project. In the center of our activities is the platform, which is considered to be the first pillar, the main pillar of our activities. This platform will be enhanced with several components that will be developed by different technical partners within the consortium. And these components are the 3 pillars from 2 to 4 that I will explain to you in a bit. And the last pillar is the open calls that will be launched by the master project to invite external entities to use our tools to enhance the platform and develop new training material. So getting into a bit more details, the first pillar, as I said, is focused on an open platform, open extended reality platform that already integrates several components. And through this platform, the user is able to create easily robotic content for teaching non-experts on specific robotic applications. The other 3 pillars, as you can see, they are grouped together from 2 up to 4, is about providing specific components that will enhance the capabilities of the platform and help the user use this platform in a more efficient and immersive way. So just very briefly, the pillar number 2 is focused on considering safety and health aspects when programming a robot. The third pillar is focused on the development of robotic applications and having virtual controllers that can control these the robots that will run in these applications. And the fourth pillar is focused on the different interaction mechanisms that will be used in order to facilitate the interaction between the human and the platform, improving the education capabilities of the platform and giving a more immersive and better understanding to the user of the training activity. And last but not least, the fifth pillar is focused on collecting technical and educational material from external entities through the open calls as described before. Here you can see a bit the consortium composition. We are seven partners. As you can see, the main components will be provided by LMS Techniker and DFKI. The main platform, the first pillar, will be provided by Virtualeap. And the last pillar that is focused more on the didactic material will be the main target of the activities for Alekop company. In parallel, of course, all partners will contribute on the validation of the education material, on the didactic material, on the enhancement of the extended reality platform, on the management of the open call for both open calls and so on. And lastly, I have just a couple of more slides and I will conclude my presentation. I would like to speak a bit in more detail about the open calls. We have two open calls. The first open call has several technical challenges. Here you can see the 5 challenges as they have been drafted so far in the proposal phase, but this is something that we are considering to see how to formulate and finalize this list. Very briefly, I will go through those challenges focusing on developing applications and developing technical components and modules in order to be integrated in their platform and help with addressing different, let's say, problems like having a handheld system application in order to manipulate the virtual resources or use different ways to interact with extended reality system like voice and gesture or AR technologies, to use AI libraries in order to create virtual plannings and to do validation in the virtual environment. And the last challenge is focused on another interaction methodology based on the gaze of the user of the platform. In the second open call, we are taking a different road, as you would expect. Here we're focused more on educational applications, and the first one is focused on machine learning application, how to create applications that use both robots and machine. Another challenge is to explain how a robot is working, how the reference systems on the robotics are working, and so on. The third one is focused more on line following applications, and this can be both for mobile robots, but also this can be for applications like welding or painting, that the end effector of the robot should follow a line in the virtual environment. And the last one is to develop general human-robot collaboration applications that are focused more in the general public and not so much to engineers and stakeholders from the manufacturing directly. Regarding the two open calls, the characteristics, let's say, are described here. In the first open call, any institution can apply and receive funding, including small companies, small and medium enterprises, large industries, research organizations, anyone that has knowledge and capability to develop a technical solution in XR environment. Here, the maximum funding will be 200,000 euros. In the case of large companies, they will receive only the 50% of the funding from the master project, and the other entities will receive the 100%. And the duration, the time that these entities will have in their hands, let's say, to use, will be 9 months. On the other side, in the second open calls, we are a bit more strict, let's say, on our requirements, having a more targeted direction. Here, the open call will be addressed to institutions that are providing education and education services and services that create new content. And this is because we want to validate the material that will be on the extended reality platform of the master project by creating a new educational material and use this educational material to the clients that the institutions already have. Here, the maximum funding will be 100 euros. Again, regarding the funding, we have the same requirements, only 50% funded for large companies and 100% for the rest. And the duration, again, here will be 9 months. So I hope it was not longer than expected. Again, thank you very much for this nice opportunity. I'm very happy and glad to be here. And I hope that this will be the starting for the collaboration, for a fruitful collaboration between the sister projects in this topic. Thank you so much.
We don't hear anything.
Okay. Did you hear me, at least?
We could hear you, but we cannot
Okay.
hear the lady.
Yeah, okay.
Okay, thank you, Milan.
Go ahead.
Welcome from my side. Our starting observation is that today hardware, as we use it every day, like smartphones and in general mobile devices, has advanced, and we have a lot of processing power and really high-level graphics processing unit with us continuously. And at the same time, all the virtual reality and augmented reality devices from the hardware level have advanced, but also from the software level, creating essentially an environment where we believe that extended reality is mature enough to be used from the broader public. And in this sense, is no longer something that should be developed inside research labs and for very specific applications. While this is the situation from the resources part, from both hardware and software, we understand that today in the US, essentially we have all the companies that dominate the market, and clearly this is something that in this project in eXtended we would like to tackle and increase the EU competitiveness in this emerging market, and essentially in a market where today we don't need to have a large-scale investment for a small company or for a startup to launch a new product. At the same time, we observe that today XR solutions are mainly applied for games and entertainment, while at the same time there are other sectors where of course there are huge benefits, and the main one is the sector of educational training. Of course, this is the focus of all the projects that we are going to hear today, but we believe that there is a huge potential in terms of training the operators, the people that work in industries, both 4.0, but those that are going to come under the 5.0, and this is where we want to focus on boosting how we can design, develop, and use XR-based applications for education and training. Now, one element, of course, is the technological element, and this is something where we have a lot of activities as part of the project, but there is also the issue of creating educational material, and this is an area where, of course, there is a big need for educational experts in order to collaborate with learning designers, learning material designers, and the XR application designers and developers. Having all this in mind, in XR to Learn, we have a pillar of technological competences like XR developers, innovators, startups and entrepreneurs from the EdTech market, hardware providers, and of course, researchers that are continuously working in this area and want to improve this technological pillar. But at the same time, we have a strong presence of researchers and professionals from the educational sector, how to build material, how to organize the material in a way such that it will maximize the diffusion of information to the students. And of course, higher level educational institutes that have a lot of experience on organizing training sessions and promoting all this material. Now, in the project, we focus on training application for the manufacturing domain. We are also focusing on distance learning scenarios. However, there is, of course, room for other kind of applications that go beyond the manufacturing domain, like healthcare, and of course, we should not limit ourselves to these areas. So one element of XR to Learn is to push technology and create all the necessary tools so that the development of new XR applications becomes easier, takes less time, and requires less resources in general. And for this, we have a series of so-called enablers that are open access software focusing on the acceleration of the development of XR applications. And at the same time, we are developing some beacon applications that essentially demonstrate how all these tools can be used to organize efficiently and effectively learning material and use it in real environments. Of course, there is a lot of effort in order to train anyone interested in developing new tools or using these tools to design and develop XR-based learning material. So this is one element, and the other element of the project is the pool of applications. So here we are going to use this mechanism, this funding mechanism towards third parties that want to design and develop new learning material using the technologies created by the project, but not only, and essentially try them out either within the lab environment or in real world scenarios in specific pilot settings where, of course, there it is important and valuable to validate the results by end users. So again, here the project will support these projects and will provide technological training, will look into open standards and carry out also at business level a lot of support in order to help essentially these prototypes evolve into successful startups and enter the market. The elements that I described from the pull phase and the push phase are organized under the so-called educational ecosystem of XR to Learn. This is based on the 8 manufacturing platform skills to move, of course, extended with additional elements developed by the project. And this is the place where we are gonna publish all the educational material produced by the project. So this is an open call to everyone that wants to collaborate with us. If you want to try out and build a new XR-based educational material, of course, we are super happy to hear about what you have in mind. In the next months, we will start by organizing okay, sorry for that. And also, if you have technology that could be part of the ecosystem, we are very happy to discuss with you and see how this can be disseminated to the community. Thank you very much.
Thank you so much, Ioannis, for your speech. And now we will invite Fotis LIAROKAPIS from Science Center of Excellence to present XR to Ed, which is about extended reality for education.
Okay, can you hear me? Or can you see me as well or not?
We can hear and see everything, so it's fine.
Perfect, thank you. Okay, good morning. Thank you for the invitation. I'm going to present you today the project that we are coordinating here at Science in Cyprus. The project is called Extended Reality for Education, and the short name is XR for ED. We are 11 partners in total from 8 different countries, and the total budget is close to 8 million euros. So the main objective of XR for ED is basically, first of all, to design a platform, an educational platform, which is going to be on demand. And I believe this is a quite innovative aspect of the project. Of course, then we have to implement and test the platform and finally maintain that for the community in the European Union. And we have to ensure of some very important values of European values like privacy, ethical considerations, and inclusiveness. And to achieve that, we have a set of smart objectives, which we split that into 3 different categories. We have scientific, technological, and business objectives. So I will start with, first of all, the scientific objectives. And the overall objective here is to enhance the XR technologies for education. And to do that, we're going to be using existing technologies. We have a lot of expertise in the consortium, more than 20 years of developing XR applications and in education as well. And we're going to bring them from TRL 4 to TRL 7. And here you can see some of the applications here, existing applications that we have. This is an application in AR, which was used for teaching university students computer graphics. The same with the second application that I'm starting now. And these concepts have been applied in practice in higher education, and were quite successful. On the second video, we see an application about teaching lighting. Again, it was for a computer graphics course in higher education. So this is the main objective of the scientific objective that we have. Of course, as I mentioned, we have technological objectives, which is, we have 2 of them. And the first one is to implement an innovative on-demand, as I mentioned, educational platform. And the second is to formulate the privacy and ethics standards for the European Union XR community, which is also extremely important. And finally, we have 3 business objectives. First of all, we have to boost the use of the platform. So we need to reach the user groups. Then we have to deliver a pan-European multi-sided platform for education, training, and learning. And finally, we have to deliver sustainable, ever-growing ecosystem for collaborating organization in diverse domains. And we all know that education has a lot of related sectors, which we try to address. To do that, we have several concepts. These are the most important. You're going to see more concepts in the next slide, but the 3 main concepts that we focus is, first of all, an XR gaming authoring tool, which will allow people who don't have the knowledge to create the scenarios and applications. The second thing is a platform, a developer platform. And the final thing, which is not used very much, not only in XR education, but in general, it's not used too much in XR, is different types of representation of humans, which we call avatars. And we're going to have different types of these human representations, depending on the learning scenario or the student experience that we want to provide. So this is our overall methodology. You can see on the center we have our platform, and then we have the ethics part and online learning courses, which are going to be feeding the platform. And then on the left, we have our developer platform. And we have another thing which I'm going to explain on the next slide, which is the marketplace. And it's also a unique selling point of the project, which is going to be inputted by repositories, libraries, and catalogs. Basically, this is an online shop, if I can call it like that. Here we have the methods. I briefly introduced you the avatars, the authoring tool, and we're going to have a gaming tool and also user interface designing. And finally, we're going to have the open calls, which I'm going to explain at the end. So in terms of the marketplace, we're going to provide a unique opportunity of having let's call it as an e-shop in a way. It's not an e-shop exactly, but it's a place where people can offer a variety of digital solutions. And when we mean digital, we don't only refer to 3D, but it can be anything which is on digital format, virtual multimedia content, for example, text, sound, metadata, anything similar to that, which is going to be built either by the consortium, of course, or by third parties. And this is going to be used for people who want to develop applications, XR applications, during the project and afterwards. The last bit is the financial support, which we're going to give for third-party projects, and we're going to use open calls. The funding is going to have 2 rounds, and we're going to fund 10 projects up to 230,000 euros per project. And we have 6 different thematic areas: virtual field trips, content creation exploitation, awareness for climate change and biodiversity challenges, training of young professionals, distance and blended learning, and finally, accessibility and inclusion. And to do that, we have 2 calls. The first call is, the main concept of the first call is to basically test and validate the platform and demonstrate that it's useful for the society and there is economic impact as well. For that, we're going to use open standards and open APIs. And we're going to have a call for developers to make these solutions their own tools, which they're going to be integrated on the platform. And the second call is going again to fund up to 10 projects, and it's going to be an open call for mini pilots to test solutions in real environments. And the trials will employ different design approaches targeting a number of end users from younger age to university students. And for the trials, we're going to have schools, high schools, university teachers, students, parents, and different institutions and companies are going to be participating. So we would like to work with you. If you want to hear more information about us, you can contact us on this email. Please mention my name because I'm the coordinator of the project, and we're happy to hear more about your interest in the project. Thank you very much.
Thank you so much for this, and also all other speakers, because now we are going to start part of our session, which is dedicated to sharing success stories on EdTech and XR technologies. The first person to join our floor is, again, Massimo MECELLA from Sapienza University of Rome. So, Massimo, go ahead, share your success story with us.
Okay, so thanks again for being here. Now I'm here with a different role, that is the representative of a big projects that we are starting in Italy and on circular and sustainable made in Italy. Is basically one of the projects that will be financed in the context of the National Recovery Fund, National Resilience and Recovery Fund that probably you heard about. Italy will invest in research a lot of money, and one of the projects that was financed was on this particular topic. In particular, why I decided to present this project in the context of extended reality, because this project, as you can see in the bottom part, will consist of many universities, basically all the top universities in learning and in computer science and industry 4.0 topics, but also a lot of private companies like Leonardo, Natuzzi, SACMI, Thales Alenia Space, that are all the big makers of industrial products in the Italian context. And the project is organized according to the concept of spoke. Basically, is a kind of aggregation of different units. And as you can see, there are specifically spoke dedicated to the topic of design and the topic of improving the factory equipment. In this context, and this is why I decided to mention, in particular, what should be investigated is how the use of AI and, in general, let's say, cloud and other computer science technology can support the making of new concept of a factory. And within this context, what we intend to investigate, and on this we hope to leverage also the results of the projects that we have just seen, is to understand how much, and experiments on the field with the big company, to invest how much the extended reality can be used as a learning instrument for workers. So to investigate not the extended reality as a, let me say, traditional for students, but as a media to improve the learning that you may have in companies about how to operate a new concept, how to make the design of new industrial equipment, how to have the co-design in a factory, because this is also a learning part. Is important in modern company. We have a lot of requirements collection. Is important for the factory of the future to be able to continuously being able to teach to their operators new techniques and new technologies, and therefore the extended reality can be used as an approach. Why this? Because of course you cannot in the current landscape to stop the operating time. So how to have a learning process can be going parallel with the production one. For this, extended reality can be an example, can be useful. I just present some very early prototype that we are investigating that are prototype. In this case, for example, we see how we have an issue in the production of the equipment is in this area. Let me show, yes. And here you see, and in the extended reality modules that you may have on the equipment of the learner, you can see how we can test if understood what are the problems that he should address. So how he's able to identify possible issue in the production by testing, like a kind of exam, let me say, the stuff on the extended modules, and the checking what if he understood correctly how to identify the issue and how to solve it. And another example of these early prototypes is this one, in which you learn how to disassemble or to reassemble specific modules in an extended reality settings, in which you live in a kind of virtual world. You have the instruction, the original instruction that you should learn because you want to learn how to build at the full speed a new equipment, and you can test in the virtual environment before going in the real production process. We really hope that these prototypes, in the context of the 3 years of the project, will benefit also of the technologies that you will be developing in your project, of course. So basically, we can play as a test bed for research that you are conducting. Thanks.
Thank you so much again, Massimo. And now we will invite Spiros Borotis from Majoli to share the success story of Bridges, which is about a hybrid physical and digital multi-user extended reality platform as a stimulus for industry uptake of interactive technologies.
Hello, do you hear me? Do you hear me?
Loud and clear.
Okay, is it better now?
Yes, much better. Thank you.
Oh, okay, thank you. Good morning from my side as well. My name is Spiros Borotis, project manager of the Bridges project. The Bridges project started on October 2020. It finishes on the coming March. I would like to share my screen as I have a short presentation. Here. Okay, do you see my screen?
Yes.
Okay. Thank you. Well, Bridges a hybrid physical digital multi-user extended reality platform, which operates as a this project in a short developed and customized platform for extended reality that has applications in non-formal learning and informal learning. In the case of non-formal learning, we implemented scenarios supporting the human capital development of the firefighters in airports, and in the case of informal learning, we focused on interactive cultural experiences. I would like to start actually the presentation with a short video. I don't know if Zoom will support also the sound, but let's test it. Okay, I don't know if the sound worked in the video, but We started the presentation focusing on the results. The business project is close to its end, so in this promo video you saw the application of the tools we developed and the scenarios. In the case of firefighters in the airports and in the case of cultural experiences. What we have here? We have here a low-cost, almost ready to get to market solution for a group interaction for oriented to learning or to entertainment, a mixed reality solution that blends the physical and the virtual space. As you saw in the video, we have an integrated system that includes a suit, a headset for the user. In some cases, the user is a learner, and a computer that is in the backpack of the learner. There are also some servers supporting the creation of the extended reality experiences and the learning management, as we shall see later. This was supported by a user-centered methodology and a set of scenarios. In Bridges, we are 9 partners coming from Italy, Greece, Germany, and Austria. As I said before, this project started in October 2020 and will finish on March 2023. And here we shall present what are the main differences and how Bridges extends reality. So currently in the firefighters training in the airports, the services use prototypes or let's say training infrastructures, so as to train the firefighters for these kind of emergencies. We see here that they have a training aircraft which has infrastructures inside creating fires. So the firefighters are called to light down fires. And how Bridges changes this reality or extends this reality. We have a mapping of the reality. You see here how we map the aircraft, the airport, even the door. We have also some designs from the aircrafts, as we saw the main differences affecting our work were mostly in particular parts of the aircraft, for example, where the pilots are or at the doors. So this is the virtual core cockpit we created. And now we see the stairs, the firefighters, the extended reality firefighters use to get into the plane. This is what they see from their glasses. We see here the fighters they see from the glasses. We have also the room preparation. As this is an extended reality case, the users or the learners are in a physical place, and they exploit the potential of extended reality so as to implement their objectives. So we had to commit particular places, both in the cultural center and the airports, furnished them with markers so as to map the place and embed it in the extended reality environment. Here is our little puppy. the programmable, a small robot we used to create the geometry of the place based on the markers. And here we have our hero. This is the infrastructure that the firefighter will use so as to engage in this extended reality experience. The uniform, the sunglasses. On the left, you can see the computer with the batteries that holds in the backpack. And here is the hero, the firefighter, using all the infrastructure so as to participate, to exploit the potential of bridges in order to get trained. On the left side, you see what the firefighter sees in his glasses. Okay, we shall present also another video with more details. So the major innovations identified here are first an improved mapping process through the programmable so as to produce the geometry of the place and exploit these markers during the learning or the entertainment experience. The decoupling of the tracking framework, the mixed reality and the object tracking, integrating real and physical objects in the virtual environment. We have multi-sensory output modules, as you will see later in the video, and the networking module and the multi-user support. Concerning the cultural scenario, this was implemented in the Hellenic Cosmos. We again created the geometry of the room. This was actually a pottery workshop. The pilot scenario in the Cultural Experience Center was taking place in a virtual pottery workshop. Here we see what the users were seeing through their glasses. For example, here we have a room with benches. We see here that we have various objects. The users could touch some of them. Here we have the avatars. And this was a copy of an object created and furnished with a sensor so as to enable the user to catch it and turn it around and being able to see it as it was in the ancient years. Now, if I'm allowed to, I would like to show you one more video, more detailed for the firefighters. And we shall close this presentation.
Spiros, thank you so much for the very interesting presentation, but I think we are running out of time. And I see your video is about 5 minutes. I was wondering if they are available online and distribute them to the participants and allow them to view them offline. Is this possible? Spiro, can you hear us? Okay, I'm afraid we will have to interrupt the video and proceed with the next presentation. Although it is super interesting, unfortunately, we don't have more time. We will make the videos available for anyone interested to check them out offline. Thank you.
Thank you, Spiros, once again. And now we will have Francesco LEOTTA from Sapienza University Rome, telling us more about the success story of CANOPIES, a collaborative paradigm for human workers and multi-robot teams in precision agriculture systems.
Thank you for your time.
You're welcome.
So good morning. Thanks for letting me present this project. This is the CANOPIES European project, which is this is a European project with many different partners. We participate as Sapienza at several different tasks. The principal investigator is Professor Gasparri from University of Roma 3, which is the third university in Rome. So what's the ambition of the project? This is a collaborative paradigm between human workers and multi-robot teams in precision agriculture settings. So we are talking about agriculture 4.0. The idea is to have a set of different robots which works together with farmers inside the vineyard. In particular, to have two kinds of robots, which are farming robots and the logistic robots. Farming robots are in charge basically of pruning and gathering all the grapes. And the logistic robots instead are in charge of moving what has been pruned to warehouses. And all of these robots must work in collaboration with humans. So in this project, there is, of course, a big component of artificial intelligence, but from the point of view of your project, from the point of view of virtual reality, what's interesting are the components that are indicated in these slides, which are the human-robot interaction component, the human-robot collaboration components, and the multi-robot coordination. So, of course, we have humans that are communicating with robots. We have humans that collaborate with robots for certain tasks. And we have, of course, multiple robots that are moving in the same environments that collaborates to the big goal of agriculture 4.0. For the sake of the project, the goal is to concentrate on table grape vineyard. In particular, this is, you can see pictures here from this pilot, which is Cooperativa Agricola Corsira, which is in the south of Lazio, where we are conducting experiments. So let's go straight to the tasks that we are taking as Sapienza. We are working on human-robot interaction. So we have a human which communicate with robots with different communication means. That could be gestures, could be voice, could be sounds, could be lights that are emitted by the robot. And the main goal of human-robot interaction is, of course, to give orders and commands to the robots, but also to have a safe collaboration between the human and the robots. For human-robot collaboration, instead, what we have is that we have humans and robots that collaborates, because for certain tasks, robots are not able to take over all the capabilities of a human. So basically, we have these collaborative tasks, long activities that are conducted by human and robots. And then at the end of the project, of course, we have an integrated system, a kind of pilot that is able to follow the production of the table grapes during all of the different phases. Now, most of the tasks that are conducted inside this project are, of course, dangerous tasks because they involve the collaboration because human and robots are also equipped. They are dangerous per se, but they are also equipped with cutting tools and tools of this type. So, what we must do is that we must, of course, evaluate our techniques in a virtual environments, but also use the virtual environments in order to train the future agriculture 4.0 farmers. So what we are developing inside the project, actually, Pale Blue is the partner in charge of developing this environment, is a 3D environment, which is a reproduction of a vineyard. And in this vineyard, what we can do is that we can basically have an interaction between the human and the robot, but also an interaction of the robot with the environment. So here you can see, for example, the commands that we have in order to let people to produce gestures for the robot. Here we have the different human avatars that we implemented for the project, and here we have an example of the interaction with the environment. So the idea with this virtual environment is basically to have the possibility to evaluate techniques, especially for what concerns human-robot interaction and human-robot collaboration inside the environment. But at the end of the project, the aim is also to use the very same tool in order to train farmers to the collaboration, to the interaction with the robots. So I've tried to be very quick in describing the project. Of course, we have many different tasks, which involves machine learning, computer vision, but I try to stick to the virtual reality part, which is most interesting for your project. If you have any question, this concludes my presentation.
Thank you so much, Francesco, for your presentation. And now we will invite Stelios ASTERIADIS from University of Maastricht to tell us more about the success story of VOXReality, which is a project about voice-driven interaction in XR spaces.
Yeah, hello, hi. I hope you can hear me and also see my screen. I am Stelios ASTERIADIS. I am an associate professor at Maastricht University in the Netherlands, and also the scientific manager of the VOXReality project. So this is the new project that is coordinated by Majoli. We are the scientific managers at the University of Maastricht, and it also consists of another 8 partners. So it is 10 partners in total across different places in Europe. But what is VOXReality? As I said, it is a recently started project, which is the Research and Innovation Action funded by the Horizon Cluster 4 work program. And the main focus of this project is to combine natural language processing, but also computer vision techniques within virtual and augmented reality settings. So in this sense, and focused on these 3 key technologies, natural language processing, computer vision, and extended reality, the idea is to see how we can make human to human, but also human to digital agent communication more seamless and quite smoother. And in order to achieve that, VOXReality is going to build on a series of technologies which we hope to push the research boundaries even further. So how can natural language processing collaborate with spatiotemporal models in extended reality applications? How can we make use of natural language processing techniques in order to infer emotions and build a more natural behavior of digital agents within extended reality? At the same time, how can we give an extra boost when it comes to human communication in virtual environments, especially when the people the humans speak different languages. So how can we build multilingual models that can also take into consideration contextual information, like the virtual surroundings, or even actual objects and their description. And yeah, as I said before, for this reason, we will make extensive research. We will conduct extensive research when it comes to NLP, computer vision, and human-machine interaction, focused on extended reality. In order to develop our tools and see them running in action, we will be responsible as a consortium for running 3 use cases. And based on the models that we will develop and that we will later on make available openly to the research community, we are going to run a series of open calls. But let me first start by describing the use cases that we will work on. So in the first use case is about a personal assistant that will be working together with a human in a manufacturing scenario. And the idea is to make use of spatiotemporal information. So what are the virtual objects that the human wants to learn how to make use of? So the training scenario, and how can the digital agent recognize the actions of the user, the questions of the user, and what is happening in the actual virtual scenario, in the actual environment. And the second use case that we're going to develop is about virtual conferences. So how can we have a virtual digital agent take care of our visitation in a conference, in a virtual conference, guide us in the different rooms? So how can we attend presentations when they are given in a language that we do not speak? So how can we have a machine translation model be adjusted to the particular topic and assisted by contextual information having to do with a specific topic, have these translations improved even further and beyond what is currently the state of the art in machine translation. Third and final use case, theaters, theatrical plays. So how can we make use of augmented reality for automated captioning, automated translations and captioning of what is going on in the theatrical play, but also taking into account the surroundings of the play, the scene of the play, and information that comes in the form of metadata injected into the machine translation model for improved translations. And yeah, as I said before, all these tools are going to require the pre-training of advanced AI models. So we will be focusing a lot on deep learning in order to bring these technologies together. And the tools that we will develop will be made available openly to the community. And yeah, we expect to launch an open call in about 1 year from now. We are going to fund 5 different projects of about 200K each. And the total duration of these projects will be 12 months, consisting of 3 different phases: design, implementation, and demonstration. And in order to boost these projects, of course, we will work with them by providing them with the technologies that we will have developed by that time. And this is more or less the timeline that relates to the open calls. As I said, they are expected to be launched in about 1 year from now, maybe a little bit more. And yeah, that's all from me. If there is no more questions, yeah, I try to be as brief as possible. Thank you very much for the attention.
Thank you so much, Stelios. And now we are continuing with Filipe QUIRINI from AWS Healthcare, Education and Government. So he will tell us more about the success story of Virtualeap, improve brain health with VR.
Hello, everyone. Let me just pull my camera. I'm not very used to use Zoom, to be honest. 1 second. Okay, I believe you guys can see me now. So let me just open the presentation. How can I share my presentation? I'm sorry to ask.
There is a green button. So it should be on the bottom, a green button with an arrow
Okay, 1 second.
right next to chat.
Okay, yes, I found it. Okay, so please let me know if you are seeing my screen.
Yes.
Perfect.
Thank you.
So my name is Filipe QUIRINI. I'm the territory manager in Amazon Web Services, and I cover the country of Portugal, which is the country where we manage the customer of Virtualeap, who is the customer that I'm going to speak about in just a second. So Virtualeap is a head tech that combines neuroscience and VR to increase the attention levels and train cognitive skills. These cognitive skills are the core abilities that allow your brain to learn, read, remember, reason, pay attention, and allow you to perform ability tasks in all the daily tasks. So what Virtualeap did was to help students strengthen these abilities. They have a team that includes neuroscientists, cognitive scientists. They did develop a proprietary game using VR to help these users improve their skills and track performance with the digital app. Right now they have 34K users, so 3430, and they are now starting to conduct clinical studies to validate their solutions for new cognitive assessments and trainings. As far as the AWS services that they use, they are using several of them. I would highlight Amazon Aurora because they are using that for scalability. They are also, of course, using EC2 for compute, also using S3 for data availability. Amir mentions in a quote that I'm highlighting in this slide that using AWS services has helped them become HIPAA compliant, which is very important when they are engaging with healthcare, and follow GDPR guidelines. They created a robust technical infrastructure on top of AWS that's scalable, fast, and secure. And AWS, provided them with the tools to scale as needed and allow them to pay based on the consumption, which of course helps them reduce costs and understand better their spending. And this is more or less the case. This is the case, very overview case of Virtualeap. Now, what I would like to also highlight is the amount of services that AWS have in place to support these kind of projects. So, of course, this slide, I'm not going to dive deep on the slides that I'm showing, but it's really relevant to mention that we can help even on the VR part. We have solutions that help you construct some models to deploy in 3D. We have servers or services that are more towards the infrastructure side, so cloud. But we also understand that it's common to wonder how cloud can develop a spatial computing hub. And as these apps get more integrated and easier to develop, cloud starts playing a very critical role in a complete spatial app. Developers will start creating layers and application layers on machine learning combined with services such as Amazon Lex, and enable streamlined methods for interaction and engagement for spatial computing. In my next slide, I have a visual example of a 3D model, but also how things can also be done on a 3D motion. Of course, there are several challenges that every entity that works in this area has. So game engines take years to develop and require significant resources to maintain. And the engines usually have auto-editing tools, animations, and they have very restricted access for them to be used, especially when we talk about commercial purposes. So it's quite important that we start having let's say an open methodology, right? So when we think about the open source, especially when it comes to 3D, we created this methodology called open source 3D engine, and the value proposition, of course, we could go in detail in lots of details on this, but due to the short amount of time, I won't be able to go there. But the main value propositions would be interoperable, reusable, and high fidelity content. The fact that it's open standards for spatial, even in the last presentation, there was lots of focus on spatial, and it's quite relevant to mention that this will create open standards for that. The acceleration of XR simulation and digital twins, and of course, the great accessibility by default. And because we know that many of these entities are actually startups, the small teams are empowered to build their own platforms. So now changing just a tiny bit, AWS has a program called Amazon AWS at Start. And this program is a program that supports what we call the edtechs. So in this area, there are several types of entities, startup entities, that are working towards supporting students using the augmented reality or the virtual reality, right? And the program that we have, the At Start, we have two different tiers. Of course, the details you can always dive deep by searching on the browser by AWS at Start and see what would be the offer that would be more pertained to a certain type of startup. But we have the innovator and the member tier. And this program is already available in 40 countries, which includes most of the countries in Europe. This is what I have to present right now. I thank you all for the opportunity, and any questions that you might have, Ioannis, you are more than happy, more than authorized to share my email. And of course, because I only cover Portugal, I will need to redirect the query to the person that would probably manage different countries, but happy to do that. Thank you very much.
Just issues with the mic, but
okay. So again, I'm presenting the project called Virtual Reality as a shared experience in the museum space. which is founded by the Lazio region, and it is in collaboration with 3 universities and the private company for the valorization of cultural heritage under the DTC funding scheme. Now, in this project, we are trying to promote the concept of mixed reality in the museum space, which presents some issues for the conventional devices, which kind of closes the users into a bubble of private experience, which is best used when you have a more extended time frame to interact with the contents, while in the museum space it is often not the case. So with this project, we invert we try to apply principles of extended reality or augmented or mixed reality interaction, but using a system of screens and projections which collaborate with the exhibited artifacts. So this is a demo that we have installed in a museum in the south of Lazio, where a number of sculptures are integrated by following the viewpoints of the user. So the user has an illusion of mixing the real objects with an extended vision. And this principle can be applied to various situations. So it can apply to situations where you integrate existing artifacts, but it can also be applied as a virtual reality exploration device, with which you can interact with zero setup time. So you enter an interaction immediately and then can explore 3D contents without learning curve. So the system is basically composed by a Kinect or other depth camera, which follows the XYZ coordinates of one user, even though other users are followed as well, but only to one the visualization is adapted. And the visualization can be then also integrated with additional layers of information, so that the user can have an excellent view of the artifacts. So with this ongoing project, we are also developing an authoring tool with which users and the content creators of the museum can integrate their contents quickly and intuitively without technical knowledge about the game engine, so that they can set up various installations, which can be vertical wall projection, horizontal screens, vertical wall screens, as well as horizontal store projections. Each of which we have a configuration interface so that users can configure it easily. So with all these supports, we have various principles of content and interaction, from integrating existing artifacts to exploring virtual spaces. And we have created a grid of possible contents that go from immediately available contents that stimulate the spontaneous exploration to longer interactions where there are a longer and more in-depth exploration of cultural contents, to gamified contents in the third row, where users can have a longer interaction. So in the first group of experiences and experience templates, there is basically only a 3D model and a few information pieces attached to certain active areas. In the second case, we have a few minutes long interaction, so users can activate a series of contents and then listen to them and perhaps do simple interactions, but without a specified order. And in the third case, since there is a gamified experience, it is important to go through a predefined set of steps in order to complete this experience. Now, all this is supported by an authoring tool, which is basically a 5-column layout. For now, we are still in the phase of this development, so I have only interface mockups, but it should be ready in about half a year. So in this summer, we're gonna have the first pilots, and the project closes in September. So basically, through this interface, the user can, the user, by which I mean the user manager or content creator, can easily insert the main characteristics of a 3D scenario and coordinates the physically present objects in the museum with the virtually present contents that are projected on the screens around the exhibited objects. So that's basically it. So as mentioned, we are still in the phase of development, but by autumn of 2023, this should be available also publicly. So that's it. Thank you very much.
Thank you so much, Victor, and thank you to all of the speakers once again and to all of the participants. I hope you enjoyed our session, and I will let Ioannis share a few last words.
Thank you a lot, Milana. Thank you everyone for joining us. And the video and all the links we saw, and of course the presentation material will be made available the earliest possible. Thank you all for participating.